Let's discuss question number 4. This is from test 5 from vibrations, which is in theory of machines. A 100 kg machine is placed in a vibration isolator of a stiffness. Okay. So you have a machine which is kept on a vibration isolator, which can be modeled as a spring and a damper. And this is, let's say, the ground. So this is the machine whose mass is 1000 kg. The stiffness, and you have the damping. So stiffness is 10 power 6 Newton per meter. Machine is given an initial displacement of 5 centimeter and released. Okay, so this is basically your free vibration. So you are giving an initial displacement and release. So this is free vibrations with damping. So when you understand free vibration with damping, you have three cases. One is underdamped. The other is when your damping ratio is less than 1. The other is your critically damped, that is just the sufficient damping, and the response, because if you displace by 5 centimeter, it will take some time for this 5 centimeter to almost become 0. So you have something like this. This is your critically damped, okay, and this is your over damped, which would take some time to, this is the response over time, and your under damped will just oscillate and come back after a small time. So this is your Chi is equal to 1. This is your damping ratio greater than 1 over damped case, and this is your under damped case when Chi is less than 1. It oscillates and then come back. The amplitude will go on decreasing exponentially and then it will come back. Okay, so in this underdamped case, we have an equation. When we derive, it comes out that ratio of the successive amplitudes, that is, let's say this is the nth cycle and this is n plus 1. So an by n plus 1 is given as e power chi omega n into time of damping, and this is omega n 2 pi by omega d, and so these are all from that derivation, and omega d is omega n root 1 minus chi square. So this value comes out to be 2 pi entirely in terms of the damping ratio an by an plus 1. So ratio of two successive amplitudes in free damped underdamped vibration. Okay, so what is asked is at the start, that is A naught, at the start it is 5 centimeter, and after 10th it is after 10 cycles the machine amplitude is 1 centimeter. So this is, so if you go on doing like A naught by A1, which is constant, e power 2 pi chi by 1 minus chi square, then A1 by A2 is also the same thing, so on till A9 by A10. Okay, so if I multiply all this, so it is basically A0 by A10, and right side will be just multiple of the same term 10 times. So it is e power 2 pi chi 1 minus chi square multiplied by 10 times. So e power, it will become 2 pi n chi 1 minus chi square, and if I take log on both sides, so log A0 by A10 is 2 pi n is 10 by chi by 1 minus chi square. So log 5 centimeter, and after 10 cycles 1, so log 5, log to the base e, remember, 2 pi 10 chi. So we have one equation for chi and we can get this. So the value of chi, if you calculate from this way, it comes out to be 0.026. I mean, if I just calculate this, take the square on both sides, and if I calculate, so this value comes out to be 0.026. So this is how your, this is one of the so it's underdamped. I mean, assume that it's underdamped, then you can just apply this formula and then you can just calculate. So the answer is 0.026. Answer is B. Thank you.